So, welcome to our GMG Academy webinar with the topic Revision of the ISO 12647-7. What is new and what changed in GMG ColorProof? Let's take a look to the agenda. First, we will talk about the ISO 12647 in general. Then we will talk about changes in the 12647-7. Changes for the proofing substrate, dot proof, color difference formulas, color measurement, spot colors, control strip, margin information, and finally the integration in GMG ColorProof 5.9. So the ISO 12647 consists of 8 parts. Part 1 describes general parameters. Part 2 is for offset printing. That's a very important one and a very well-known part. And part 3 to 6 for the other printing technologies. Number 7 describes the proofing process. That's the one we are talking about today. And number 8 describes validation print. That defines parameters for the color management in production printing with toner-based systems and large format printing. All parts are linked to each other, as changes in one part might be relevant for the other parts too. This means the changes in part 7 for proofing influence the other parts as well. So a short look into the history of 12647 Part 7. We had the first version in 2007, a first revision in 2013, and the actual revision that had been published in 2016. Changes in the ISO standards are discussed over years in technical committees of the ISO. For the printing industry, it is called TC 130. Very important to know, the revision 2016 replaces the previous version. They are not valid in parallel. One remark regarding the ISO wording. The differentiation between shall and should is very important. Shall means it is a requirement and should means it is a recommendation. This is something that is discussed very often and handled very sensitive. And the wording certified field proof means a proof that is measured and validated with a media badge and is used in a daily life. The foreword of the ISO 12647-7 contains an overview about all relevant changes. Some smaller inconsistencies had been addressed. Substrate and measurement specifications had been adapted to industry relevant criteria, e.g. the revision of ISO 13655 of 2009 for measurement technology had been considered. Then we have a first basic support for spot colors. That's still far away from a standard that considers spot colors comprehensively, but it's a first step. We have a terminology and a wording that has been updated, and the most important change, the CIE delta E 2000 color difference formula had been added. So the first topic that is defined in the revision is the proofing substrate. The revision contains a new definition regarding permanence, means light fastness and fading for the substrate itself and also for printed colors on this substrate. There's a need for tolerances and a clear definition that allows the storage of proofs and the usage as a contract proof over a longer period of time, and this is now clearly defined. Furthermore, the revision contains some specific rules for the white point of the substrate. It shall allow a colorimetric match to the simulated printing substrate with a delta E 2000 smaller or equal 3. For example, the defined paper tint of foregraph 51 is L95, A 1.5 and B -6, and this paper tint has to be simulated in proof with the delta E smaller or equal than 3. This means the white point of the proofing substrates is normally a bit lighter as the printing substrate to enable a simulation in brightness and color. And normally the white point of the proofing papers are designed to match the paper tints of the common printing standards with a simulation of nearly delta E of 0. In the older versions of 12647-7, it was defined that the paper tint of the proofing substrate has to correspond exactly to the printing paper, but this had nothing to do with proofing. So the next one is a new definition for dot proof. Dot proof means a screen proof that is usually based on the customer 1-bit data that are used for the print. The usage depends on the region and the printing process. Partly it is used in offset, but mostly in flexo. And there's also the possibility to rip the data in the proof rip, e.g., or for example, if the final ripped data is not yet available. This does not correspond 100% to the final output, but it gives already an idea, and therefore some rules are defined. The first one, the halftone proofs should have the same screening frequencies or screen rulings as the production press print to be simulated within a tolerance of 3 lines per centimeter. This is missing here in the presentation. The second one, the halftone proofs should have the same screening angles with a tolerance of plus or minus 3 degrees as the production print to be simulated. This is important to identify Maury effects. And the last one, halftone proofs should have the same general dot shape as the production print. This is important to identify this plays a role for coarse screening frequencies. There, the dot shape plays an important role. It depends if it is round or more elliptic. For the screening frequencies of 175, there plays no role as it is nearly not recognizable in the proof. Very important is that the standard defines the documentation of all parameters. Screening frequency, angle, and dot shape shall be reported if they differ from the proof. So if you rip your data with your proof rip to make a dot proof, all differences to the final 1-bit data has to be documented. The most important change is the switch to the color difference formula. A color difference formula describes the difference of 2 colors to each other in the LAB color space. The classic standard formula is delta E76, or also called delta EAB, that describes the color difference as a quadratic equation. If we define a tolerance for each color in delta E76, then this tolerance range has the shape of a sphere with the defined color in the middle. The problem is that this does not correspond to the human perception. Especially in very saturated colors, we perceive colors difference as much smaller as the calculated with the formula. And other way around, in gray colors, we perceive the differences much bigger as the formula tells us to be. We are much more sensitive in gray colors as in saturated colors. There are also other formulas like delta E CMC or delta E2000 that has been established, that has established itself as it describes the human perception of color differences. If we define a tolerance for a color in delta E2000, then this tolerance range has the shape of an ellipse with the longer side in direction of the chroma. An example: also for observers that are used in comparing colors, it is very difficult to perceive differences in saturation in yellow. It is difficult to see the differences and to say if these are 2, 3, or 4 delta E. But color shifts in direction to a more orange yellow or a more greenish yellow can be perceived and described clearly. Delta E2000 takes these aspects in account and rates differences near the gray balance or color shifts in the hue angle more sensitive. The revision of 12647-7 replaces delta E76 with delta E2000. Delta E76 is not longer used. It is not possible to convert from one formula to another, as delta E2000 is much more complex and takes into account some weighting parameters. It might also be possible that you receive different values from the color differences depending on the formula. This means proofs that are in conformance with the old standard must not be in conformance with the new standard, and other way around. We did some tests at GMG and measured over 100 proofs with both formulas. Let's say 10% didn't pass with the old formula and 10% didn't pass with the new one. Partly this had been the same proofs with the same patches, but partly and more seldom this had been different proofs with other patches. So it was not the aim of the ISO to tighten the tolerances. They had the aim to enshrine a formula that describes better what we see to ensure comparable quality between visual and measured result. Here we can see a comparison of color difference tolerances in detail. On the right, the old tolerances with delta EAB or delta E76 and delta H for a CMY neutral scale. On the left, the new tolerances with delta E2000 and the changes for CMY neutral scale patches with the new criterion, the delta CH. When we take a closer look to the tolerance values, in the past we had over all patches an average of 3, now we have 2.5 and a maximum of 6, and now we have 5. For the substrate we have no changes in the tolerance values. For the solids we had in the past 5, now we have 3, and we had a delta H of 2.5, and now that's the same with 2.5. For the CMY neutral scale, we have a change of delta H to delta CH. Delta H describes the hue tone angle. This makes sense for high saturated colors, e.g. the primaries or the secondaries. But close to the gray axis, the delta H reacts very sensitive. This can lead to very high values, although the delta E differences are low. The delta CH describes the color differences in the AB dimension. That makes more sense for the evaluation of differences of gray colors. And therefore we have now an average value and also a maximum value. And last but not least, we now have a tolerance for the spot colors, but we will talk about this later. So, for the color measurement, it is generally defined that it should be made with D50 and 2 degrees standard observer. Furthermore, it shall be made with the measurement condition that was used for the creation and of the characterization data. The FOCA characterization data up to FOCA 50 was created in M0. This means the proofs for these standards have to be measured and verified with M0 also. The newest datasets, FOCRA 51 and FOCRA 52, and the future ones are created in M1 and have to be verified also with M1. This means you must know the measurement condition that was used to define the printing standard. And this is also for custom standards. So we had some changes in the rounding of measured values. In the past, no decimals had been defined in the tolerances. Partly this led to different interpretations in different softwares for proof verification and left room for errors or misunderstanding. Now they defined the rounding with the same precision as the defined tolerance values. The numbers are rounded off to 1 decimal place. An example, a delta E value of 5.49 was rounded to 5 and was in tolerance in the past, although it is nearly half in delta E. Now this value is out of tolerance as the tolerance itself is defined with 1 decimal as 5.0. This means we get a higher occurrence and standardization. Also an important change are new rules for the verification of spot colors that are used in the proof document. Spot color solids and tints, including at least a 50% patch if a definition is available, shall be verified on a wedge with a tolerance smaller or equal delta E2000 of 2.5. This means for colors of the Pantone books, no tints are available in the official database and they cannot be proved and compared. For the colors of the HKS books, tints are available and must also be proved. What wedge is used for the spot colors? Every proofing software uses an own layout. At GMG we use an extra strip. In the next years we can expect a standardization of these wedges. Spot colors that cannot be proved in tolerance as they are out of gamut, or special spot colors like metallics or pastel tones have to be identified on the proof. So regarding the patch definition or the layout of the control wedge, we have no changes. We still have our solids, our mid and shadows, our black tone scales, and our CMY neutral scale patches, and some tertiary colors. The only thing that is new are the patches for the spot colors. So let's talk about margin information. The standard defines which information has to be written in the margin line under the proof. There are no changes so far. In GMG ColorProof we have defined presettings to ensure that all necessary checkboxes are set to ensure that the margin line corresponds to the ISO definitions and contains these informations here. So what about the integration in ColorProof 5.9? In ColorProof 5.9 or Proof Control 2.3, we verify the proofs per default with the new criteria. So we recommend the update to the newest versions to ensure that the new criteria is used. Now on the left you can see the old label on the proofs with the old tolerances with delta E and delta H. On the right you see a new label with delta E 2000 and delta C H max and average for the CMY gray patches, and the new tolerances that are defined. Additional on the right, a sample for a spot color verification with maximum and average delta E2000 for all spot colors on the wedge, and yes, for all colors and the in-gamut colors. As target values for the spot colors, we use the LAB values from the spot color database that is linked for proofing. Here you can see how the wedges for Epson X900 with embedded measurement device would look like. On top the media wedge version 3 and below the media the wedge for the spot colors that are generated on the fly from the software. Up to 10 spot colors can be placed in this wedge. For further spot colors, a second wedge will be generated and printed below. The spot color wedge is called New Spot Color Control Strip version 2 in the UI of the software. Here we can see the general settings in ColorProof. In the Proof Control Inline tab, a checkbox is activated now for the verification with the new criteria. The checkbox is set automatically after update. Users who want to prove with the old criteria can deactivate the checkbox. One little remark regarding the checkbox above. Color difference formula delta E76. This is only for the old spot color control strip version 1 and is not relevant. So let's have a short overview. Delta E 2000 replaces delta E76. Delta CH replaces delta H for CMY neutral scale patches. We have the spot color verification, and we have the margin information that must be printed below the proof. Here you can find our sources for this presentation, the ISO standards revision 2007 and 2016. We also used the FOCRA ISO News 21 and the FOCRA Extra 36 that describes the new specifications. Just take a look on the FOCRA homepage and you will get more information. And the media standard print 2016 from the BVDM is also available in English and includes the latest changes. So if there are further questions, don't hesitate to contact us. I want to recommend further webinars of our GMG Academy. The first one on 9th of May. What means extended color gamut? Which inks are best suited to extend the CMYK gamut? What is the actual technology? How do we support ECG? Everything about ECG. And we have some upcoming trainings in our academy in Tübingen. One on the 17th May about GMG ColorProof best practices. And we offer all trainings on request. Further details you can find on our Academy homepage, gmg.com Know-How Academy. Here you can find our contact for sales and technical questions, as well as for training and knowledge, our Academy email address. And that's it from my side. I thank you very much for your attention and for listening. Bye-bye.